My main TrueNAS server has 96 terabytes of usable hard drive space, and it's just sitting right behind me in the server room. However, I have already started to fill that up. It is 75% full between client backups, old videos, my own backups, and things like that. So now I have gone ahead and bought 8 24 terabyte hard drives, and we're going to be expanding my 96 terabyte NAS all the way up to a 240 terabyte NAS by adding in 8 of these 24 terabyte drives, and that number is usable space. If you've not seen it on the channel before, I actually run a custom built TrueNAS scale server that I use as my primary NAS for my office. It has about 14 terabytes of SSD space and another, well, about to be 240 terabytes of usable hard drive space in it, 128 gigs of RAM, NVMe SSD caching, and all the great stuff that ZFS has to offer. And I primarily use it for both video editing and also storing backups of all my servers. And for clients that I manage their servers, I will often create a backup of their server, keep it on my server. The way it ends up working is I have them set an encryption key. So that way their data is on my system, but I don't have the encryption key to decrypt it. So what we've got to do though is we've got to go ahead and expand it. So the primary chassis that I got that holds all my hard drives has 16 bays in it, and I've only populated 8 of them so far. So that is really useful because we're not going to have to install any new actual hardware other than just these drives right here. The other thing is I'm running ZFS. TrueNAS Scale runs ZFS for everything, and so adding the space is going to be trivial. We're not going to have to mess with LVM or anything like that. All we're going to do is just add these drives as a RAID Z2 VDEV to my primary hard drive pool, and within about 5 minutes, all that storage space is just going to be online expandable, ready for me to go. ZFS is incredibly easy to expand, and what's essentially going to happen is most new writes are going to start going to this much larger space. I'm actually going to talk about it while we're actually installing it and kind of talking about how it's going to work. But what it's going to give us is a really easy way to just add more and more space. So if this happens again in another few years, I can literally just go ahead and buy another 16 terabyte chassis, plug in some new SAS cables into it, add it to the expanding volume, and just like that, we will be able to add in another 16 drives. And we can just keep doing this as long as I have money in my pocket and power through the wall. And so the drives that I'm doing are these 24 terabyte Iron Wolf Pros. I bought them with my own money. I reached out to a lot of companies and none of them wanted to send me a few $1,000s worth of hard drives. I absolutely understand. And so I ended up buying them myself. These things have been awesome. I've been playing around with them in other servers and they perform really well. Obviously, if you've watched this channel before, these are the drives I really like, and 24 terabyte drives are awesome. These price per terabyte are almost identical to a 16 terabyte drive price per terabyte. What that means is you can go for these larger sizes and not be paying a premium for that extra space. Back in the day, the largest drives were so much more expensive and we're only getting like 2 extra terabytes than their predecessors, the smaller versions. And so those last 2 terabytes were costing you insane amounts of money. Now, it is almost the exact same price in price per terabyte, which is awesome. So currently I've got 16 terabyte drives in there. That's how we've got the current 96 terabyte array. But now we're going to be really going up to the big leagues by adding in 144 terabytes of usable space, nearly 200 terabytes of raw capacity on this thing. So the chassis I'm using for this is a super micro board. So I've got my screwdriver, I've got my drive trays, and I have my screws. So I'm just gonna go ahead and get started. All right, last one, and I'm realizing I did something that I always tell people not to do. I've gone ahead and I have screwed all of these in without actually testing one of these. So there's like somewhat real chance that these are the wrong screws and are going to jam on the side when I try to put it in, but we're here, and I think they fit pretty flush. And just like that, I have all 8 of my drives in their caddies, and now they're just going to be ready to be placed on in. So what I'm going to go ahead and do, plug those on in, and go grab my laptop, and we're going to go ahead and add this VDEV to my actual ZFS array, and we're going to just immediately have that extra space and show how it works. So let me go do that. All right, and just like that, they're gone ahead and plugged on in. So let's just go ahead and connect to the server and check out and add those drives on in. All right, so as you can see right here, I'm running TrueNAS SCALE. And if we look at our storage, we can see that we are very close to being full. Really, you try not to get these systems over about 80, a really hard line of 90% full, just because of performance degradation and all that good stuff. And so what we're going to want to do is we really need to expand this. Now, ZFS expands in a very different way than something like adding a drive into a RAID 5 or RAID 6 array. There is the ability to have VDEV expansion that I'll cover in a future video, certainly, but the easiest way to expand ZFS is just to add more VDEVs. The way ZFS works is it effectively has these things called VDEVs, virtual devices. So the closest analog for people who are coming from like RAID 5, RAID 6 would be RAID Z1, RAID Z2, and RAID Z3. And essentially the way it works is you just create these little arrays and then you add them together to get more space. And the cool thing about the way this works is all you have to do is add another one, and then every time ZFS writes, it basically looks at which of the VDEVs is most empty, as well as which one can accept a write sooner, but it's primarily based off most empty, and will bias the data to be sent there. So that means over time, it is auto-balancing. So what's going to start today is the 63 TB of data that are currently on my array are not going to go anywhere. They're not going to move to any of the other disks. But as I write new data to this, it is more likely to be written to the new disks. And so over time, as I delete stuff and as I add stuff, it will slowly start to even on out. And that's how it works. So if you're looking for a very performant system and the data is basically going to be fixed and there's not going to be a lot of deletes, ideally you would want to expand sooner than this, because now this 63 TB of data is kind of trapped on that system. And so if I was looking to get the very fastest speeds out of this, I am leaving a little bit of performance on the table because those files are only ever going to be on those disks rather than on both of them. So you will lose a little bit of performance in theory. For me, I'm not worried about it at all. This is far more performance than I need with a hard drive pool. But I did just want to mention that. But now we can see that we've got these 8 assigned disks. And what we're going to do is we're going to add them to a pool. We're going to add them to an existing pool and HDD. By the way, you'll see that all these units are in what's called TB. In reality, they are the 24 terabytes you're expecting. Just multiply them by about 1.1 due to the difference between a terabyte and a TB. So now all we have to do is just, hey, add. And we are going to do our normal RAID Z2 setup. We're not going to add anything else. And you can see right here, we are going ahead and we are adding in 8 24 terabyte, which is 22 TB, into this thing in a RAID Z2 array. And that's going to give us a estimated raw capacity of 131 TB, which is 144 terabytes. And now, just like that, we can just hit update pool. And I didn't have to shut anything down. Everything could keep working. And funny enough, there's no performance degradation during this. If you've ever added in like RAID 5 and you know there's that massive time where your pool's slower as it's reshuffling data and it's kind of dangerous, this is not that case at all. Basically, the entire thing is built and runs up right then. In this case, it is complaining at me because we've got mixed VDEV capacities. So if this was a ultra high performance system and that was really the focus of the system, was to be the highest possible performance, yeah, this is not the best thing. In an ideal world, you would have all the exact same VDEV size, just so you don't get asymmetrical loading of data across them that I was kind of talking about earlier. This does not matter for me whatsoever. I mean, it's still going to be fast. I'm still going to be able to pull multiple gigabytes per second off of these hard drives. And you can see instantaneously all of that capacity is there. So now I have gone from being 75% full to being 30% full. And the cool thing is, all of these are just going to slowly trickle on in. A really nice thing that ZFS does have as well is if I mess this up, ZFS actually has optional functionality to just removing data on out. So you can actually remove a VDEV after it's been added, even if data is crept on it. So what would happen is basically it would just take all the data that was on that VDEV and move it to all the other available VDEVs, which if I wanted to kind of rebalance this pool, I could kind of do that. It's not necessary to do that for my case at all, as I was saying earlier, but just another thing we could do. And just like that, the space is here. So now I have basically 240 terabytes of usable space on this thing. And it was just that easy. I'm gonna go ahead and hook up my 10 gigabit connection, and I'm just gonna go ahead and dump a file to it, and we'll go ahead and see what kind of performance we can get off of this thing. All right, so the way we're gonna test this is I've hooked up to my old videos, which is one of the shares that is actually stored on that hard drive volume, and we're gonna go ahead and just dump it on over there. And we're gonna look at this number to see what kind of write speeds we get to it. So we can see right off the gate, we are getting 800, 900 megabytes per second, which we are definitely losing a little bit of performance because of the way it was set up. In theory, if these were both empty to start, we should be pretty easily able to saturate that 1 gigabit connection on the back end, but this is still very fast for hard drives. And as they kind of balance themselves, especially most of the things I've got going to this are things that are added and deleted over time. Time machine backups, server backups, and a lot of things like that that are constantly changing, constantly making modifications. As time goes on, these pools will basically optimize themselves. If I never deleted anything off of them, it would take a while and I really should have expanded much sooner. But because my data primarily does add and remove itself on its own, just based off the way it's set up, it will be going through and basically rebalancing itself as time goes on. And even as it's in balance right now, we're still getting about 800 megabytes per second. So now the reason that this is slow is the imbalance I was talking about. So right now, what it's going to do is it's going to be dedicating a lot more of the writes to the new hard drives, but not all of them. It's got an algorithm there to basically choose which VDEV to write to. And when one of them is very full and one of them is very empty, the algorithm's a bit inefficient because it's really focusing on making sure you've got your raw storage capacity as balanced as possible for reads, rather than worrying about anything else. So because of that, we do lose a little bit of that performance on the table, and that is also why we get this warning over here about the fact that we've got imbalanced VDEVs. That is because when you do have mixed capacities, you do lose a little bit of performance. But in most cases, and in my case right here, it's performance that you don't even notice about missing. And that was it. That was how easy this was to expand out that data, and that is one of the really nice things about how ZFS works. ZFS just allows you to add space by just adding more VDEVs, all online, all without taking a hit to your current performance, and in fact, only making it faster. All right, well that's going to be it for this video. If you liked it, subscribe, and if you want to hire me, there's a link for that down in the description below. All right, have a good one. Bye.